All right, algebraic reasoning. This is your semester one exam review. Might look a little different than ones you've seen before, but this is one that our team made. And so we'll just go through this. It's only 11 questions long. Here we go. Parent functions, functions that aren't transformed in any way. So describe the graph of a linear function, right? So a linear function's parent has a slope of 1 and it goes up and to the right, a straight line through the origin 0, 0. Let's add a little, can we draw? No. Okay. So just so y'all know what it would look like for number one. So linear. The straight line through 0, 0 goes up 1 over 1, looks like that. So you just describe that in your own words. All right. Number 2, describe the graph of a quadratic function. The graph of a quadratic function looks like a U is called a parabola and either opens upward or downward at either a maximum or minimum vertex. All right, and just to get a picture of what that would look like, here's the parent function of quadratics. It goes through 0, 0, and it looks like that. That's quadratic, also known as a parabola. All right. Number 3, describe the graph of an exponential function. Okay, it depends if it's exponential, growth or decay. Exponential. Goes forever to the left without touching the x-axis and exponentially increases. Right. And then exponential decay exponentially increases to the left and goes forever to the right without touching the x-axis. So let's do a little picture of that. When it comes to exponential growth, okay, it goes through 1, it goes up like that forever, and then it gets closer and closer and closer to the x-axis, but it never does. And then decay is kind of flipped around. So it goes forever like that, and this gets closer and closer and closer. And just to kind of be more precise over here, it's going exponentially increasing. That's exponential. Back to no. Here we go. What is the parent function of a linear equation? Y equals x. What is the parent function of a quadratic equation? Y equals x squared. And you can get that by hitting this little keyboard, and that's your squared button, right? What is the parent function of an exponential function? All right, so bring it back to where we were. exponential growth parent function and decay parent function is when it says b to the x, where b is greater than 0 or less than, sorry, greater than 1 or less than 1. Where were we at? Here we go. So y equals b to the power of x. Sure. B could be 2, B could be E, B could be something, as long as X is in the exponent. All right, number 7. Domain is a set of all possible X values inputs, and range is a set of all possible Y values outputs. So how do you know when to use parentheses or brackets to express domain and range in interval notation? What clues on the graph are you looking for? All right, so parentheses are for open values that are not equal. The graph will have an unshaded circle. Brackets are for the closed values that are equal. The graph will have a shaded circle. And we can do an example here. So let's go back to the graph. I made my notes here. All right, let's talk about domain. Domain is always x, which is from left to right, right? So my domain, how far to the left is this point right here? Well, that's -1, comma. How far to the right does it go? Well, it goes over 3. Now, what matters for interval notation is the bracket or parentheses. So at -1, right here, the x value, this is open, and open means it does not equal, so we use a parentheses. And for 3, though, that is shaded in, so that means it includes it, so we're going to use a bracket. All right. Now for range, that's your y values, that's from bottom to top. We'll start with the bottom. How far down does this go? Well, this point is at, on the y-axis, -2. And then the top point way up here, the y value is 4. So let's see, the bottom value we started with, -2, was open, so that's parentheses. Top value was shaded in, that is brackets, okay? So that's a reminder on how to do interval notation. Open is open is parentheses, shaded in is brackets. All right. How do you evaluate a function for a specific element of a domain? For example, how would you determine that? Okay. So to evaluate a function, you must replace or substitute the variable. In this case, it's going to be x with the given value inside the parentheses of f parentheses. So for example, the one they gave me, f parentheses 3 equals 3, and instead of x, I'm plugging in 3 plus 2. Well, that 3 times 3 is 9. 9 plus 2 is 11. Okay, so you're basically replacing x with a value. All right, number 9. How do you determine if a table values represent a linear function? A table of values represent a linear function if they have a common difference. If you add or subtract by the same number each time. X change. All right, and let me give you an example of that. And we did this back when we talked about, I think, exponentials. What number are we on? That's 9. Whoops. So if my x's are constant, increasing by 1, and then I see something like this, well, each time it's adding 2, so that's called a, oh my gosh, common difference. Even if it's adding each time, it's called a common difference. And that means it's going to be a linear function. It would be a straight line when I graph it. Okay. Common difference means you're adding or subtracting by the same number each time. All right. But what's the next one? How do you determine if the value represents exponential functions? Okay. So I'm gonna just modify what we just did. Common ratio. You're going to, instead of add or subtract, you're going to multiply or divide by the same number each time for a constant change of x. Cool. So let me show you what I mean by that on number 10 here. So let's say you have this table, and again, your x's are going to be constantly changing up by 1 or something like that. Let's see, I have this 2, 4, 6, oh, something like this. Okay. Now I may start to say, hey, I added 2, and then I added 4. Uh-oh, it's not adding each time. So I would kind of think about it again. What about multiplying? So that's times 2, and that's times 2, that's times 2, that's times 2. Okay, so what happened is we found a common ratio, and ratio means you multiply or you divide. Okay, so common ratio means it's going to be exponential. It's gonna look something like this when you graph it, right? Exponential. All right, and then last one, what is the formula for determining the axis of symmetry of a quadratic function from the equation? Okay, well, uh, it's always x equals the x value of the vertex. Okay, how to use the information to determine the vertex. All right, and that's not something that we had specifically gone over, but what we did go over looks like this. Okay, so first of all, the vertex for this, the x value is 3, the y value is 2. So my axis or line of symmetry is always x equals number, and it's always x equals this x value of the vertex. So x equals 3 is the equation of the line of the axis of symmetry. All right. That's a brief little review for your final exam. We're keeping it brief, and for the exam, keeping it brief. The most important thing for you to do is to make sure that you've passed T1 and T2, your first 9 weeks and your second 9 weeks. So that's your priority. Make sure you're working on that, and then you can study this review and also study your reviews for your other unit tests, and then you'll be ready to take that final exam and pass this semester. All right.